Hey Chan Physics, Mr. Block, and I'm just going to embed a couple videos into this GoFormative that you guys are doing on Tuesday. Kind of a combination of all the things that we've been learning. So remember what we learned. We learned those three things, that in a position versus time graph, the slope is the speed. And then in a velocity versus time graph, the slope is acceleration. And then we'll get to the last one later, where in a velocity versus time graph, the area under the curve is the distance traveled. So this one will test those first two things from our notes. And so you can see that what we have here is your GoFormative. You have a position as time graph, and you can see that there's actually four different segments of that line. So each one is separate. And I'm going to do an example for you guys. Since there's only two of these, I'm not going to do this one right here, but I'm going to turn on the camera and do an example for you so that you can see how to do it. So let me get that camera up. So here I have a problem where it's the same thing that you guys are going to be doing in problems 1 and 2, or bullets 1 through 8, I think it is, where you have four segments. So 1, 2, 3, 4, actually 5 segments of the line. And they're going to ask you for the speed at each time. So remember that first thing that we learned was that the slope of each line segment is the speed in a position versus time graph. So how do we find the slope? Well, we find the slope of each segment separately. And the easiest way to do that is rise over run. And so the first one is pretty simple. We have 0 starting here in 0 seconds. So we have a 0 rise and a run of 2. And so that first segment, the speed is 0. All right. Now we have this second segment, the one that goes from here to here. And so we can have a rise, you can see, from 0 to 25. So we have, for this segment, 25 is our rise over 2 is our run, right? Because from 2 to 4, that's only 2 seconds. So that's 25. And so we'll get 12 and a half there. The third segment right here, we have a rise again of 0, right? Because between 4 and 6, we have no rise or negative run. And so we have, again, it's 0 over 2 or 0 again. And then here we have two segments that are going down. And so what we should notice is, number one, is that our slope is negative. And we can find that pretty well by just using rise over run. What's the rise of this segment? Well, it's from 25 down to 15. And so that is negative 10. And then our run is 2. Okay. Okay, again, from 6 to 8 is just 2 seconds for this segment right here. And then the last segment right here, we have a rise of negative 15, right? From 15 down to 0, so negative 15. And again, our run is 2 from 8 to 10. And so the way you guys would be putting these in, I hope this one's in meters per second, but look, when you guys do your problem set right here, you can notice that the units are in miles and hours. And so the speeds you should be getting here are miles an hour. And so I've got it set up here so maybe you guys can see the first one, but you see the rise here in the first one is 15 and the run is just 1. And so we get, for the problem number 1, we should be getting 15 mi per hour. So just so you guys don't get frustrated, 15 mi per hour would be the correct units, but we're accepting miles per hour or miles per, and then HR. Okay, so you're going to do that for all 8 of these. All right, and then the next thing is here, they're asking you for the acceleration. And you have to notice that this is a velocity versus time graph. And so this is the second thing we learned in a velocity versus time graph. The slope of this line is the acceleration. So you'll just have to find the acceleration here, 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 and then there's 2 here. So we'll do that. And I'm going to cut this one off, and then I'll make another one for the second page.